started. Okay, we're going to look at another question. We'll look at another question. Look at another question. Said two bodies start from rest with different accelerations A1 and A2 to attain velocities V1 and V2. Give you anything we do. When it goes, then you continue. Okay, velocities V1 and V2 in t seconds. Which of the following equations expresses the relationship among V1, V2, A1 and A2? Question A1 over A1 equals to V2 over V1. This will be A2 over A1. B, V1 over A1 equal to V2 over A2. C, V1 square over A1 is equal to V2 square over A2. Option D, V1 over square root of A1 is equal to V2 over square root of A2. And finally, option E, you have V1 over A2 all square is equal to V2 over A1 all square. Solution. Let's look at this problem. Is a two bodies start from rest with different accelerations A1 and A2. So for body 1, when a body starts from rest, its initial velocity is 0. When the body starts from rest, its initial velocity is 0. So initial velocity of body 1, which is u1, is equals to 0. That is it when you're looking at the concept of rectilinear acceleration or uniformly accelerated motion. When the body starts from rest, its initial velocity is 0. Okay, and it moves with an acceleration a1. So the acceleration of body 1 is A1. To attain a final velocity V1, it attains a final velocity. V1. Okay, in t seconds. The time taken is t seconds. Now we look at body 2. Alright, before we go to body 2, the motion we are going to use now, there are about 4 equations of uniformly accelerated motion. And we are going to look at that. But before that, let's hold on. You say for body 2, the initial velocity of body 2, please let's listen. The initial velocity of body 2, u2 is equals to what? 0. Remember I told you that they both start from rest. 2 bodies start from rest. That means that the first body started from rest and its initial velocity was 0, and the second body also started from rest. Its initial velocity is 0. Now the acceleration of body 2 is a2. Acceleration of body 2 is a2. Okay, and then it attained the final velocity v2. V2 in a time t seconds. Okay. Now, like I said previously, prior to this time, that there are about 4 equations of uniformly accelerated motion. Now, what are those equations? The first equation is this: V equals to u plus at. The second one is S equal to ut plus half at squared. The third is v squared equal to u squared plus 2as. And lastly, we have S equals to v plus u divided by 2 multiplied by the time t. That is average velocity times time. Okay? Now, which of them do you think will be convenient in solving this question? First, you analyze the parameters given to you. You have the initial velocity, you have the acceleration, you have the final velocity, and the time t. So I believe that the first equation will work, because we have final velocity here, we have initial velocity, we have acceleration and time. But this other one that has distance, initial velocity, time, acceleration and time, then this other one has both final velocity, initial velocity, acceleration and distance. These ones will not work. The equation which will work is that of equation 1. So we are going to use equation 1, which is the first equation of uniformly accelerated motion. We use equation 1. In solving that question, we are using this equation in solving the question. So we'll apply equation 1 to body 1 and body 2, and we'll see what we get. Okay. Now what do we obtain there? I say from equation 1, that is the first equation of uniformly accelerated motion, v equals to u plus at. Now for body 1, this will be, say for body 1, this now will be what? v1 equals to what? u1 plus what? a1t. Of course, we know that the time is constant. The time is constant for both bodies, time and time t. Alright, now what is u1? u1 is given to us as what? 0. The body started from rest. So it then implies that v1 will be equals to 0 plus a1 times t. Alright, so this is v1 equals to a1t. Now what happens to body 2? Let's look at body 2. Body 2 then becomes for body 2, all they have,
that big one.
For body 2, you have v2 equals to u2 plus a2t. So v2 equals to u2 plus a2t. Okay? Okay? So Alright, so this now is what? V2 equals to, in place of U2, what do you write? 0, right? So this is 0 plus A2T. And you'll be having V2 equals to A2T. Now, let's look at that. If you can recall vividly, we are trying to establish the relationship between V1 and V2. Okay? Now let's make T the subject of formula from here. So if we call this, we can call this equation asterisk 2, and call this one equation asterisk we call this equation asterisk 1. Call this equation asterisk 1. Okay, so we are going to make T the subject of formula. Say from asterisk 1, from equation asterisk 1, that V1 is equals to A1T, right? Now, divide both sides by the coefficient of T. The coefficient of T is what? A1. So this now becomes what? V1 divided by A1 equals to what? A1T divided by what? A1. This will eliminate this. And you're having that what? Time T is equals to what? V1 over A1, isn't it? Okay? Now, we are going to look at equation asterisk 2. Let us make time the subject of formula there. So, we'll be having, you can call this equation asterisk 3. Asterisk 3. So, from asterisk 2, what will you have? From asterisk 2, equation asterisk 2, you're having V2 equals to A2 times T. Divide both sides by the coefficient of time. Coefficient of time here is what? A2. That will be V2 over A2 equals to A2T over A2. This will cancel this out. And having that time is equals to V2 over A2. You can call this equation asterisk 4. Now what you simply do is to equate both equations. Equating the both equations, you'll be having you have say equate asterisk 3 to asterisk 4. So asterisk 3 is V1 over A1 equals to asterisk 4 is V2 over A2. Alright, so I believe at this juncture we have arrived at the answer. That is option what? What were the options? That is option B is the answer, of course. Option B is the answer. V1 over A1 equals to V2 over A2. That is it. So we have established the relationship between V1, which is the final velocity of body 1, V2, which is the final velocity of body 2, A1, the acceleration of body 1, and A2, the acceleration of body 2. We have established a relationship between the four parameters. Okay. We'll solve the last question for today. We'll look at the last question for today. The last question for today is on velocity time graph. On velocity time graph. Let's look at it briefly. On velocity time graph. Pause it.